Right, we're going to create one script, and I'm going to show you how you can create very, in simple terms, just creating an orbit. Like you see here, I've got 3 planets orbiting a sun and 2 moons orbiting their respective planets. All right, so let's go ahead and dive in. And to start off, this is very simple. It's nothing complex in terms of a scene. What am I missing? Where's my moon? There it is. Moon 2, get out of there. Nothing too complex. We just have a couple of sphere meshes added in, and they have their materials on just to give them color, differentiate them, a little bit of variation in size. All right. And their actual positions when it comes to the orbit will be set automatically for you, so you don't need to set them up. They just have to be in the scene. And the only one that you have to physically place where you want it would be, in this case, your sun, where all the planets are orbiting around. All right, so let's jump into the actual script. So what we're doing is we have a couple exports here. We have the target, which is what we're going to orbit around. We have the speed, which is going to affect how fast we're orbiting around. Of course, makes sense, right? Speed. The distance that we're going to be away from the thing we're orbiting. And if you would like, a starting angle. So if you have maybe 2 objects with the same distance, you can have them start at 2 different angles. Right, makes sense. Let's say, for example, you had you created a planet and maybe it's got 3 moons, but you don't want them to be colliding with each other, so you give them different distances. Right, and then the current angle is just keeping track of where our planet currently is in its orbit. All right, so inside of its process, the first thing we're going to do, we're going to do a null check. So if target is equal to null, we'll push the error no valid target to orbit and just exit out. And if you do have one, then we're just going to do the current angle. Just open this up. So current angle plus equals degrees to rad, our speed times delta. And then we'll have 2 variables, one for x, one for z. And these are going to function pretty well the same. Target.globalPosition.x plus the cosine of start angle plus current angle times our distance. For z, we have target.globalPosition.z plus the sine of start angle plus current angle times distance. And then we just set our position using those values. So global position equals a vector 3, pass in our x. We're just going to use target.globalPosition.y because we don't want to change our height in our orbit, and pass in our z. And it's as simple as that. In my case, I'm extending node 3D. That way I can just stick it on anything. Right? I could stick it on a mesh. I could stick it on a rigid body, a kinematic body, whatever it is. Right? That way you have a little more freedom in what you want to use, but of course that's up to you. But with that, all you have to do is just come into the inspector, tweak the speed, distance, starting angle, and select a target that you want to orbit around. So my planets have picked the sun, and my moons, of course, have picked their respective planets. And that's all you have to do to get yourself an orbit working. All right, that's a nice simple script to get us going after the 2 heavier explanatory ones in the last couple weeks. All right, that's it. Before I ramble on, take care. Have yourselves a good day.